Hello everyone, we're still on the scenario 1, looking at the EKS cluster compromises as part of this Kubernetes tech series. And we're picking up where we left off in the previous video. If you missed that, link is in the description. Here we'll look at the detection for the attack that they performed, what logs we need, and how to spot malicious patterns, such as node creating a token for privileged service account, as well as cluster enumeration, which usually doesn't happen using the node's service account. Let's do a quick recap of the attack real quick so we know what we're looking at. So again, this is scenario 1, we're still on it. So first thing we did is we got a remote command execution via command injection in the vulnerable Flask application. Then we accessed IMDS version 2 from a pod to enumerate what service role it's using. Then we install the credentials for the role from the EC2 node IAM credentials. Then we did some reconnaissance on the EC2 instance, look at the tags, what it does. Then we used the IAM role to exchange the roles credentials for the EKS token so we could enumerate the cluster. Then we enumerated the cluster using the identity we got, the EKS token, to list all the pods and see what permissions we have. Next one, we found a privileged production pod that seemed like it had a very privileged service account. So we request a service account for that pod, and we got the full cluster admin after doing that. So in this part, let's look at the detection and explore what logs we need, what we don't have in this lab, and see what the difference is, how we could spot this malicious pattern. So if we go to detections.md, you can actually see all the logic and what we need. Let me actually walk you through real quick. So first we'll look at the visibility, and again we'll reference attack matrix, Kubernetes attack matrix, if it's gonna load, hopefully. So first thing first, we got an initial access via application vulnerability. Then we used cloud to pivot. Then privilege escalation, we found what's the base? Oh, credential access. We got the service account credentials. Then privilege escalation, we access cloud resources, and then we got another container service account, and that we used to exploit a cluster admin binding and had all the admin privileges. So that's just for reference if you want to compare to the matrix. Now let's look at the logs we need. So first one is up RCE. So it's something that we are not gonna see because we would need runtime logs from the application. So if you're using something like Wiz to do runtime protection detection, that would pick up on that. For the IMDS v2, again, you would need to use Wiz or GuardDuty. Because I'm on the free tier, I don't have it enabled in my code. But all the other phases we can detect. So first one is STS get-caller identity using EC2 and the Skype tags. This is enabled by default in Cloud Title Management events, which we'll look into. Then node reconnaissance, basically it's unheard of for the EC2 node EKS cluster role to perform any kind of reconnaissance. It just doesn't do that. So the fact that signing kubectl get pods and looks at its permissions, it's very suspicious. So for this, we need to enable the EKS control plane logs, which we do have and we'll look into. Next one is token escalation. Again, we just need EKS control plane. We'll look into this. Usually you don't see node creating tokens for other pods. That just doesn't happen. And last one is, again, enumeration and verifying privileges. You usually don't see this type of thing in the cluster. Maybe once in a while, admin has to do this, but you can quickly verify. But if you've seen any of the other signs, you can actually compare it by looking at the agent, I mean the user agent that's making the request, and looking at the source IP. And you can kind of contrast and compare, like, hey, is this an expected IP or is it something I should look into more? Which we'll see in the demo in a minute. So you can go through this. It does more explanation and gives you all the CloudWatch queries. But let's go hands-on and see what we can actually see. This is my AWS account. So first thing first, we go to CloudTrail history, and we can see that the node is doing STS call, and if we expand the logs, we can see that came from this IP, which could be one of yours, maybe not. And we can see the user agent, which can be changed, but we can see that it's from Parrot OS, very suspicious, and from AWS CLI. Usually you don't see nodes trying to do STS get-call identity from AWS CLI. They're using their own client, so this is very suspicious. So this is step one. Next, let's look into the actual node activities. So first one is actually node impersonation and request and service account token. So the query would look like this. Select the run query. Doesn't like this one. That's just working. Let me pause the video real quick and figure out what is wrong with this query, because it was working just a minute ago. Okay, now it's working. We just had to specify the actual log group. So here, log group is perfect standard, but you have to select one, the one that has been configured. So essentially that's why it wasn't working. But yeah, back to the video. So first one, this query is looking for node impersonation and request and service account token. If we look at the logs here, so essentially it's going to query all the Kubernetes audit log and look for create and for service accounts. So if we look at the normal activities, essentially user agent should always be a kubelet, because it's gonna just create a service token on startup of a pod. That's about it. But if we look at our command, when we create a token, we can see that it came from non-AWS IP first. This is our attacker's IP, and it came from kubectl. This kind of what gives it away. If we look at normal versus abnormal, normal is kubelet traffic uses kubelet user agent during pod startup, and abnormal requests come from interactive tools like kubectl request and token. So here we can see our attacker. So this would give it away. So we can potentially search for the source IP and see what else it did, and we can look for this user agent as well. Here you can filter out the normal traffic just to see what abnormal looks like. Here you can see that it created token for service account, for namespace prod, for object reference name prod admin say, which is our pod, and it used source IP of this IP and used kubectl instead of kubelet. So yeah, hopefully this kind of makes sense what makes it different, because this is not normal activity. It's coming from unusual non-AWS IP. Instead of using kubelet, which is by default on every pod, it's using kubectl. So let's look at another query where it's performing enumeration. because node account, as you can see, it would never perform enumeration. All it's responsible for is to do watch to make sure the pod is running when it's supposed to, and it creates a service account token on the startup using kubelet. So here, let's look at the enumeration activities. The query would look like this. Again, they're all on my GitHub. So we're looking for username, system node, which is default, Kubernetes service account that's being used by the node. We're looking for resources, pods, namespace, surfaces, and self-subject use. This is what API looks like when somebody does enumeration, or like, hey, what can the list, what permissions do I have when I run kubectl of can I dash list. This is what lists the permissions. And we're looking for verbs get and list, and user agent is not like kubelet because by default it would only use kubelet. So essentially, if we filter out kubelet, we'll see the abnormal activity. We click on. Here you can see that our malicious attacker, the same IP, same using kubectl, the same user agent, tried to look at all the pods. He looked at the payment processor twice, which is very abnormal. Then tried to list all pods, and again, tried to list all pods, and it got permission denied. Next one is we'll look at the cluster admin abuse by the pivoted service account. So essentially, let's see what the actual service account did that we impersonated. So here we can see who am I. Essentially, these are commands like, hey, who am I and what can I do? Usually you would not see those, and looking at the previous artifacts, we can see that the same source IP, the malicious one, and user agents is also kubectl, the same one that we saw before, which would give it away like, hey, this doesn't seem normal. This is an attacker doing enumeration of my cluster. So we expand on this. Again, same compromise node. Source IP is the attacker's IP. Usually consider this like, if you're a global company, it might be a bit difficult, but if you're just based in Canada and this IP is from somewhere else, this might be a clear indicator that something is wrong. But yeah, it's a command to always look for those, set up the decks for this enumeration commands, and try to see who is doing what, and look at the user agent, because usually you just set up automation and there's no like testing permissions. Testing permissions only happens when you're doing some sort of troubleshooting, and you can always reach out to your cluster admins and be like, hey, are you doing some kind of troubleshooting? And it's useful to have an alert for these types of commands. There's another query we could run. Basically, it gives you the same thing, like what the account did. Yeah, two of the same queries, that just gives you a little bit more information. Right off the top. Still learn about CloudWatch syntax. It's very new to me, so just learn with you guys as I go. But yeah, essentially, here's how we could detect it first. So we see the get caller identities from something weird, like node is called sts get dash caller identity from strange IP from strange user agent, and then it would pivot to CloudWatch logs, not CloudWatch, CloudWatch. We would see that system node is doing some activity using unusual user agent. Just disappeared on me. Set more hours. Logs are overwritten. Oh yeah, here it is. Essentially here we can see that instead of kubelet, kubectl is being used, and from a non-AWS IP, which is a clear indicator that somebody compromised their node and doing something strange. Then we'll look at the account performing enumeration. So essentially looking at all the pods, listing all the pods, enumerating the pod metadata to forge a service account token. And lastly, we can see what the service account did that has been impersonated. These days, you can just create specific skills for to look for these types of attacks and just use some type of AI tool, but still good to know what is happening behind the hood so you could see what is abnormal versus what is not normal versus what is normal. But yeah, essentially, I hope this helps. I recommend playing around with this a bit more, look into all the fields, try to detect the full chain of the attack, like what happened, and understand how we can stop it. And which we'll actually look into in the next video. We'll look at the incident response portion of it, how we could prevent this type of attack if we catch it live, to make sure there's no privilege escalation, there's no additional persistence established. And yeah, hope you guys enjoyed it, and I'll see you in the next one. Bye.